So these are your ionic bonding notes. Cations are positively charged ions. These form when an atom loses one or more valence electrons in order to obtain a noble gas configuration. So just as a reminder, whenever I'm talking about losing electrons, that means I am losing negative charge. So as I become less negative, I'm becoming more positive, and so that is how we get our positively charged ions. The noble gas configuration is simply the electron configuration of a noble gas. So our first example, our noble gas is neon, and it has an electron configuration of 1s2, 2s2, 2p6. So if I'm looking at sodium, which is likely to become a cation, it has an electron configuration of 1s2, 2s2, 2p6, 3s1. So just a reminder, valence electrons are electrons that are found in the outermost energy level of an atom. And when I'm looking at electron configuration, the energy level is found by these first numbers, the big numbers. So the 1, 2, 2. So the electrons in both of these twos, right, that gives me 8 total electrons in the second orbital, or energy level, I'm sorry. And then 3 has 1 electron. So I would say this 1 electron is my valence electron because it's the only one in the outermost energy level. So sodium can lose this 1 electron in order to get the same noble gas electron configuration up here. And I just want to mention that even though it will have this electron configuration, that does not mean that sodium becomes neon, right? It will still be sodium, it just will have 1 less electron. And when it does that, it will become charged. So it will be sodium with a charge of +1. Transition metals are kind of funny when it comes to cations. They tend to lose the electrons in the outermost s orbital, which is 2 electrons, giving them a charge of +2. However, because they do have those d orbitals in there, they can lose different things to get a number of charges, depending on what chemistry is taking place. So if I'm guessing what a charge is for a transition metal, +2 would be a good safe bet for a guess. And throughout this unit, we'll go over different exceptions to that rule. So for today, we're going to talk about these 3 that can have a number of charges, but the main ones are +2 and +3. So iron, actually iron in your blood, depending on what it is, if it's bound to oxygen or not, can have a +2 or a +3 charge. Copper can have multiple charges, as can nickel. Anions are a negatively charged ion. So these occur when an atom gains electrons. So again, that's a gaining negative charge in order to achieve a noble gas electron configuration. So for example, if I have the noble gas argon and its electron configuration, and then I'm looking at chlorine and its electron configuration, I notice that if I gain 1 electron in this last p orbital, that I will obtain a noble gas configuration, making chlorine very, very stable. All right, so if it does gain an electron in this orbital, then it would have a charge of -1 because it has gained 1 negatively charged electron. So when we're talking about ionic bonding, it's a chemical bond, just in general, is the force that holds 2 atoms together. All chemical bonds involve the electrons in the outermost energy level, or valence electrons. Specifically with these notes, with ionic bonds, those occur when an electrostatic attraction occurs between a cation and an anion. And all that means is that whenever I have something that's positive and something that's negative, those 2 forces are attracted to each other and kind of pull together. Ionic compounds are compounds that contain ionic bonds. There are a number of kinds of ionic compounds. The main 3 that we're going to talk about are oxides, so that's between a metal and an oxygen. Salts occur between a metal and a nonmetal. And most of these are binary, which means that they're made up of only two different elements. So if I'm talking about a sodium and a chloride, or calcium fluoride, right, that's only two different elements as opposed to things that have more than two. So how do we go from ions to compounds? Compounds generally do not have a charge because charged things tend to be less stable in different situations. And if I'm made up of, something, I don't want to be made up of unstable things. So we need to make these charges balance to where we have neutral compounds. So if I'm looking at sodium chloride, which for those of you who are not aware of what this is, it's table salt. If I draw the Lewis dot diagrams for sodium, which has 1 valence electron, and chlorine, which has 7 valence electrons, this is what they look like. So earlier when we were talking about the formation of cations and anions, we were talking about gaining and losing electrons. Now we can't just gain or lose them from, the abyss. They have to come from somewhere. So in this situation, in order to achieve the noble gas configuration, we would say that sodium would lose this valence electron. And in order to achieve a noble gas configuration, this chlorine would gain 1 electron. So we would say that it moves, and we'll say chlorine steals the sodium because it's more electronegative, or it's more hungry for electrons, and gives itself, and they both get their noble gas configurations. And so at this point, they're charged, right? Sodium has a +1 charge because it just lost 1 electron, and chlorine has a -1 charge because it just gained 1 electron. And so the thing that makes them ionically bonded is these charges draw them together. And that attraction is their ionic bond. So when we write the formula, it would be NaCl because the charges balance, right? We have a +1 and we have a -1, and we have 1 of each of those charges, so it balances. So when I'm writing the chemical formulas, always write the symbol for the cation, or the positively charged ion, first, followed immediately by the anion. Where people tend to get confused with this is that they include spaces, commas, or whatever, because it just feels weird to put two things back to back. But with chemical formulas, that's what you do. So some more practice with going from ions to compounds, a little more complicated example. If I'm looking at calcium fluoride, all right, calcium, in order to achieve a noble gas configuration, in this case would need to lose these 2 valence electrons. But fluorine already has 7 valence electrons, so it only has room for 1 more, right? So we would have calcium give 1 of the electrons to fluorine, which would give us calcium with 1 remaining valence electron. And fluorine, there should be an 8 here, with a full octet, or full 8 valence electrons. So in order to get this valence electron gone as well, I would need to add a fluorine, another fluorine atom, that electron could go to. So that gives me a calcium with a +2 charge, right, because it lost both of its original atoms, or electrons. And then it gives me 2 fluorines with a -1 charge. So you'll notice if I say, okay, -1 plus -1, that's a total of a -2 charge. And then my positive charge had a +2. They balance. So my charges have balanced. And so my chemical formula would be calcium, or CaF2, because I have 2 fluorines. Okay? And that's the end of your notes today.